My name is Nicholas Popp. We're currently at the National Eye Institute in the National Institutes of Health in Bethesda, Maryland. I'm working on a disease called Age-related Macular Degeneration, which is an eye disease that affects about 5% of the population. What we're doing right now is trying to figure out why people get it and what we can do to treat it. I'm originally from rural southern Illinois, basically in the cornfields, and there's not much science going on around there. So I didn't really get any sort of introduction to it until I went to college, actually. So I went up to the University of Chicago, and when I was there, during my second year, I got introduced to a basic research experience through a summer program, and I fell in love with it. My boss, very first day, took out a model of a protein, and he basically, it fit in two halves, and he pulled it apart and turned it about 30 degrees and snapped it back together. And he said, when the protein does this, the cell dies. And that small movement, literally like 30 degrees, was absolutely fascinating to me because it meant that something as small as a twist could determine the cell fate and how that would happen in humans later on. You know, if you have a lot of cells do that, then they die. That can lead to a lot of different problems like the disease we're studying here. With people who have AMD, it could lead all the way to complete blindness. Typically what we see though is you start losing your central vision, right where I would be looking at your face and not so much on your periphery, things that you detect with motion. What'll happen is as your eyes start to deteriorate more and more, that will actually begin to expand, and so you'll start losing more and more vision, sort of centrally radiating outward. In terms of the disease genetics, we're trying to figure out which ones have it. If we can get one of those and get one of those published, then we have something that can actually be quickly moved into the clinic and be used as a diagnostic in the future. On most day-to-day basis, I'm actually in here doing a lot of things like looking at different histology slides of samples that we've taken from like eyes, or we have some patient samples that'll come in as well. Other times I'm actually trying to validate this in other ways, so we're using to test the same drugs on the human cell lines, sort of give us some more preclinical data. And I do that over in the cell culture hood. Lots of pipetting, lots of taking care of cells in the incubator, you know, very typical basic lab stuff. We do have some really great images that are fluorescently labeled, so you can see like how the cells look based on where different proteins are expressed in the cell. So right here, I have a set of what are called RPE cells, retinal pigmented epithelia. So you can see that they're really, really dark. So these are actually from a human patient that came in a few months back. And so what I do is I basically just have to change the media on these. I'm sort of this is basic what you do with cell culture stuff. You just keep them alive. And so I'm just gonna be changing the media so that they don't get sick and die. Everything in here has to be extremely sterile, so anything that goes in has to be wiped down with ethanol. Anything that comes out has to be taken care of. This is a special media that one of the other labs in the National Eye Institute has developed for these cells to make sure that they don't go bad. So I can't tell you most of what's in it because it's a lot of chemicals, but it's nice and bright red. I actually have a rare disease, and so that's been a big motivating factor. And so for me, looking forward, being able to get this experience here where I've been able to do some basic drug trials is really fascinating, has really kept me going on that path and sort of solidified that's what I'm going to do going forward. There is actually a lot of collaboration in this lab. We just did the injections this morning, right? Mm-hmm. But so around the 21st, is that probably good?
And you're talking about the fundoscopy, right?
Yes, we're talking about the fundoscope. So we'll take pictures of the retina and see if any of the lesions have changed. We get samples from all over the world, not just from locally. I mean, last week we had some samples come in from Italy. And so we look at those, we analyze them, and we get back to the doctors and we say, here, this is what's going on with your patient. We can tell because of this. We also have projects going on with people out in Kansas City, out in Oregon, all over the world. So it's really a collaborative environment. It's been pretty great for me here. And honestly, what makes me so excited about it is because I can do so many things with research. I'm at the cutting edge of what is happening and what is known. And if somebody comes in with a rare disease to NIH, I can be one of the first people to look at it and say, we see this, and this is what that means for this patient. Take some time to explore science. If you're really interested in it, there are so many different things that you can do and so many different ways you can sort of look at how things work or how the body works or what can go wrong, that there's something you'll find in there that you'll like.